Welcome back, team. Okay, alright, team. So, in our previous class, we understand the importance of HA and DR when it comes to database. Now, we are going to see how exactly and how we can provision a database in the cloud environment, how we can make a connection to that particular database as a business user or as a stakeholder. So, that part we will see now. Okay. To see that, as usual, we'll need to go to the portal. I'm just going to the portal, team. There, you just take any of the database. Any database is fine. You can refer MySQL or Postgres or Cosmos, whatever it is. For time being, I'm just considering Postgres. Okay. Later, I'll bring MySQL also. But for now, I'm just showing you the Postgres. So when you go for the Postgres, Azure database for the Postgres Flexi server, Azure database, Postgres SQL server, and Postgres SQL server Azure Arc, you are seeing three types of databases and another one Azure Cosmos DB for Postgres SQL cluster. You are seeing different types of Postgres SQL databases and corresponding servers. But my suggestion always here is go for the Flexi server. There is an advantage with the Flexi server. So each and every cluster, each and every PostgreSQL server has its individual importance. But PostgreSQL flexible servers is the best case which you can consider for your projects. Why? What is the reason for that? The reason behind the Postgres Flexi server is whatever the scenario, whatever the discussion we made yesterday, especially for HA, you can see the standby replica, and for the DR, definitely you can make the DR backup in another region. All these features exactly fulfilled at the PostgreSQL flexible servers. The mainly flexibility. What is flexibility here? The flexibility is whatever the database you are just provisioning, the standby replica is there in another zone. That flexibility is there with this flexible server. So that is an advantage of the flexible servers. So that is why initially I'm preferring the flexible servers. Alright, so once you are here, go to the flexible servers and click on create button. Okay, alright. So now you know very well that there is a resource group which we created in our class. That is AZ-RC. I'm selecting the same resource group followed by the server name. Coming to the server name, I'm just giving the server name as Postgres, or just you can give anything, okay, ADO, AZ or something like that. I'm just giving. So this is your domain name as well. This is your server name or domain name, okay, which you need to refer later when a stakeholder or the business user is trying to connect to this. Then where exactly you want to deploy? I want to deploy this one in the nearby region. That is a common basic principle which we will follow, right? So just go there and I'm just preferring Southeast Asia. I'm selecting Southeast Asia. Go for the PostgreSQL version. I'm just picking the whatever the latest is there. I'm just picking this particular version. You may get out in real time who will tell us which version exactly we need to provision. Those information especially you can get either from cloud architect or from your developer, because they use it to already using this kind of architectures in their local environment. So they know very well that which PostgreSQL actually they are trying to connect. Try to use the same PostgreSQL. And interesting thing, workload type is production, large size, development. This one also. Now why they are differentiating different types of workloads. The production small, medium, production large size, and development. You can prefer anything, but since our case is a demo case, usually you will go for development. Not only this case, even in your real time lower environment also you can prefer development. Then what makes the difference here? What makes the difference? Nothing. They will just recommend one set of compute and storage, but still you can override that. Still you can override that, not an issue. For instance, I'm just going for the production and small. See, they are just telling, hey, please use the minimum as 2 core and 8 GB one. If you go for the production large size, they are just changing that one to the 16 GB RAM and 512 GB storage. So they are just recommending, it's a recommended option, okay. I'm just going for the development. In that also, I'm going for the config server. I'm opening the config server. Click on this one. It will show you another screen here. If you notice this one team, there it is talking about different types of compute types. Is it burstable or general purpose or memory optimized? That is the first thing. Okay, so coming to this one, burstable, general purpose and memory optimized, you can choose this type of workload based upon your application behavior. But initially, no one knows how exactly our application will behave, because this is the first time you are provisioning your application database, At that time, really you don't know how the spikes would be. But don't worry. So basic rule, just go for the general purpose one. That's the best case which you can prefer always. General purpose one, which is a balanced configuration for the most of the common loads. But these are again preferable based upon your scenario and your application behavior. For example, you are bursting your CPU to certain level. So your CPU utilization, your application is consuming your CPU of the database like anything. Then you will go for the burstable, because this can easily tolerate if you are using high-end CPUs, if you are utilizing the high CPUs. No, your application is consuming more on the memory, meaning that whatever the queries the developers written, if those are impacting the CPU or those are impacting the memory, you will correspondingly select these two. But my suggestion is, don't be very specific on that, just go for the general purpose one. Once you are okay with this, there the compute size is the one which are recommending, just open this one. See, if you notice this one, again they are just giving some name, some series name, some D2 DSV4, D4 DSV4, D8 DSV4, something like that, and 2 cores and 8 GB RAM and the 3200 input-output operations. Now my point is, how to select which compute size is exactly suitable for you. Again the same question. This particular thing, again team, I'm stressing. You are setting up the database for the first time. In your real time also. First time you are provisioning the database. No one knows what would be the compute. No one knows what would be the compute. But how do we know which is the right compute? To know the right compute, after performing some non-functional test. After performing some non-functional test, what is non-functional test? Usually, whenever the project is being kickstarted, at the time itself, the client will give some requirements saying that your application should be able to handle 100 concurrent users or 1000 concurrent users during the peak hours. That is a non-functional requirement. So what you will do, you will just select one configuration D2 DSV4 here. You will form the architecture and you will go for non-functional test. We will go for non-functional test. Then you will understand whether really your application is handling 100 concurrent users or not. For instance, your application or your database compute, whatever you selected, is not able to handle 100 concurrency. Then what you will do? You will come here, you will increase this one. You will just upscale. You will upscale it. Hey, that infrastructure not really enough for me. I need to scale it up. But when you know this one, when you are done with your non-functional testing, where you will do the non-functional testing? You will do the non-functional testing in the pre-prod environment. Why you need to do the non-functional testing in the pre-prod environment? Because the pre-prod environment, the production environment, configuration and infrastructure is same. This is a sequence of links, okay? You need to keep in your mind, okay? Alright, I'm just giving you the basic one. You don't need to go the high-end one again here, because after non-functional testing only you will modify this one, okay? Until then, it will be same. Next one, storage. Again, this one also same case. See, this particular storage, but interestingly, they will not charge you too much for your storage team, okay? For instance, whatever the selection you are making, for instance, I'm just selecting 1 terabyte of storage. If you notice this one team, there you are seeing, okay, This is compute charge, this is storage charge, right? That is what exactly you are saying. Now if you notice this one, the compute is costing you $180 nearly, 180 US dollar. So why? Two cores, because two cores are there. Each virtual core is costing you $90. You no need to buy hard anything, huh? No need. You no need to remember anything. Just understand the concept here. Okay, 2 into 89.06. Okay, fine. It is giving nearly 180. And there is a storage, but each, if you notice the 1 terabyte of storage is 1 terabyte. If you notice this one, each GB is costing only 14 cents. 14 cents. For example, maybe minimally in real time also, you will start with 128 GB. Just start with that and understand the application behavior and how that is going through during your test itself. Then itself you can understand. Okay, I believe if 128 GB is not really enough for you, then you can upscale it. You can upscale it. Now tell me, I'm asking one question, Tim. Okay, one interview question. You selected the database size as 128 GB today. You went to production. But 128 GB is not really enough for you. How you will know that? Is there any way to know that? If you know, or what exactly you will configure? Repeating the question again. Today you configured with the database size as 128 GB. Okay, you move to the production. During the production, this size is not really enough for you. That happened in the production, okay? Then how you will come to know that? Yes, this size is not really enough. If you know that, what action usually you will take? Do you require any downtime for that case? I'm just asking a question then. You just try to attempt, not an issue. Think about it. Before the class ends, you can attempt that, okay? Not an issue. Let me go further. And there is one interesting option which they are giving, storage auto growth preview. Whatever the question I asked, this is the solution actually Azure is providing. But if Azure is not, this is in preview. If it is in preview means it's not available for the general public. It's not available for you. You should not act in these kind of features in real time. You should not. Because this is under testing mode. Okay, under testing mode. Not GA yet. GA. Okay, it's not GA yet, meaning that generally available. It's not available yet. Okay, it's not available for the public. You should not select this one. So what storage auto growth? What exactly they're talking about? For example, in real time, when they know this database size is not enough for you, they will upscale it automatically from there. They will upscale it. So that is the point exactly they are doing. But if we don't have this feature, so far we are doing without having this feature, right? How we need to achieve this one? Okay, think about it. Next one, high availability. I stress this one like anything in our yesterday's class. This is the high availability section. Enable high availability. Just click that one. Now, if you see the high availability mode, two types of modes it is recommending. One is you want to keep high availability of the database within the same zone or another zone. Now I'm just going to the diagram, whatever the part we have seen yesterday. So meaning that this is the standby replica. Standby replica is sitting in the same zone, or standby replica you want to keep in another zone. You may get some doubt. Hey, why they are keeping standby replica in the same zone? Our scenario is zonal failure, right? If zone failed, these two will be out. Then definitely your app will not be served. Then why they are recommending? See, in the same zone case also, repeating again, same zone case, you know very well, zonal redundancy, you know very well. This zone gone, I think this particular database sitting in another zone will help you. That is very clear. But when two databases are in the same zone, for example, this particular database will be under one data center. This particular database will be under another data center. If only data center failure happened, still you can make use of this database. If zonal failure happened, you cannot make use of any of this database. But if it's only data center failure, you can make use of this database. That is the purpose of in-zone redundancy. That is the thing exactly, same zone redundancy. But point you need to remember, point you need to remember. Whatever may be the case, when you go for the high availability, when you check in this option, your charges are double. 319,638. Your charges are double. You need to inform your client saying, hey, your database is being charged monthly $600. Will that be okay for you? You need to ask your client or customer. If you say yes, of course you can proceed. Okay. Otherwise, you should not. Next one, backups. Especially, the advantage with Azure here is, not only Azure, even AWS or any cloud environment, usually they will take a backup by default. Okay. They will take backup for 7 days. 7 days of backup always they will ensure. If you need more backups, especially for other days also, you can increase this one to 35. Up to 35 days of backup you can store. But by default, Azure will store last 7 days of backups with you. Okay, if something happens, easily you can restore from the backup. Restore means reprovisioning the server again. If database corrupted, you will reprovision the server again. You will restore the server again. That is what exactly the backup advantage. What kind of backup redundancy you are using? By default, it's a local redundant. That's what exactly I mentioned. Though you are taking a backups, right? For example, go for the diagram. If you see, these are the backups, right? All these backups are local redundant by default, meaning that all backups whatever the Azure is taking, they will keep again 3 copies with Azure. Each backup, okay, 3 copies. No, I don't want that. I want to replicate that one in another region. Of course, yes, just click this option. It's a geo redundancy. That is what exactly we have seen. Keeping the backups, especially in another region. This is what the geo redundant backup. Once you are done with this, I'm just saving the feature, but I don't want to save this one because this one will cost like anything for us. I'm just removing those two. Okay. Just again, even here also, that's the minimum one. That's good. And another, because our case is demos, right? You don't need to take a high configurations and all. That's a minimally I can keep it. That is what exactly I placed now. Just save it. Okay. Done. Compute and storage configurations done. Then I'm just going, so another one. So this is your wish, where exactly you want to keep your flexible server. I don't have any preference. Better don't select any preference, not really needed. They'll make sure any one of these things available to join is available. For the primary they are talking about. This is for the primary. High availability, oh, I haven't enabled this one, leave it, okay. Right, next one is authentication. How we can connect to the database. So I'm just giving some username here. And I'm just giving the password also. I'm just giving some password also. Okay, you just need to pass the same thing here also, team. Okay, password also. Once you are done, just go for the networking. Once you go for the networking, here it is asking public access allowed IP addresses. So what does that mean? This is an important area, okay. You want to keep your database as publicly available or within the private. If you consider the real-time cases, real-time use cases, always we will keep the database inside the private, correct? That's a basic rule. Another basic rule, team, okay? Always you need to keep your components inside the virtual network, inside the private area only. Always remember that one. But our use case, if you remember our use case, what are the use case we are discussing now? So in this particular use case, your database and app service both are available publicly. That is what the scenario we are simulating. So I'm selecting public one. Once you are done, there are firewall rules. You know the firewall rules means, though you make your database publicly available, that doesn't mean that everyone can connect to that. That is impossible. What Azure did here, Azure added a firewall to the database. Those whoever have the access whitelist their IP address. What is an IP address again? If you come here, go to your missions, okay. You can just go for the my IP address or something, or ipchicken.com, or another site is ipchicken.com. So if you go for this particular site, so usually you can see your IP address. Okay, what is your IP address exactly, which is representing your mission? What are the IP address you are seeing on the screen, team? Okay, what are the IP address? Even you can refer some other IP site also. What is my IP address? This is also fine. Okay, what are the IP address you are seeing on the screen, team? That IP address you need to whitelist here. Remember the point. Okay, remember the point. Sorry, I haven't discussed for the last 10 seconds. I just saw the screen got blank. Okay, sorry. Able to hear me, right, team? Able to hear me, right?
Yes.
Okay, fine. Okay, so under the firewall rules, we need to add our IP address. That is one thing which we need to keep in our mind. Okay, I'm not adding anything now. You just go for the security. Under the security part, data encryption. So whatever the data you are storing to the database, when it is inside the database at the storage area, again, they will encrypt that data by using their own key, or you want to provide our own key. That is another thing. Usually we will not touch these areas, especially the service managed keys, because we already trust Azure clouds. We already trust the cloud. You no need to again worry on encryption part which is happening when your data is getting stored. You no need to worry. Just keep this one with their service managed key only. You no need to modify this. Go for the tags. Especially I'm just giving here. I'm just giving some owner or whatever the tag. Okay, whatever the tag usually we will follow. What was the tag usually we followed last time? Anyone remember? I don't recall that one. It's okay. I'm just giving the project. I'm just giving the project as tracker. Don't worry. We'll follow the same tag. Once you provide the tags, what is the tags useful? Why we need to define the tags? Tags are useful to differentiate the cost when the bill is generated. Remember that one. Review and finally create. Now it is asking an option, create server without firewall rules. You want to add the firewall rules. Return to add firewall rules. I don't want to add for now. Just create. Okay. That's all about the PostgreSDB provisioning part. That's all. Now we will wait for some time. This particular database will be ready for you. Thank you for the session. See you in the next part.